Welcome back to the deep dive. Ready to explore another fascinating scientific paper with me today?
Absolutely. Always excited to delve into these thought-provoking topics.
So, today we're tackling a question that blends science and philosophy. Could we, could we actually detect traces of a past civilization, like way back in Earth's geology?
Whoa, that's a big one. You're talking like a civilization predating humanity, leaving its mark in the rocks.
Exactly. That's the whole idea behind the Silurian hypothesis. It's this wild concept that we might not be the first intelligent beings to have left a footprint on this planet. And there's a research paper that digs into this whole question.
So we're going full-on geological detective here, looking for clues in the rock record.
You got it. But I think it's safe to say that finding evidence of a long-gone civilization, especially one that might have existed millions of years ago, comes with a unique set of challenges, right?
Oh, absolutely. I mean, think about it. The further back we go in time, the more fragmented and, well, incomplete the geological record becomes.
Right, right. It's like trying to piece together a puzzle with half the pieces missing.
Exactly. I mean,
Yeah.
even finding fossilized evidence of a species that existed for a relatively short period, like us, like Homo sapiens, is incredibly difficult.
So, just imagine the odds of finding traces of a civilization that might have predated us by
Yeah.
millions of years. Okay, so this research paper we're diving into, it focuses on a specific period, right?
Yeah. It covers this massive span of time between, let's see, between the rise of complex life on land, so roughly 400 million years ago, and the mid-Pliocene, which is, around 4 million years ago.
Wow, okay. So we're talking about a huge chunk of Earth's history here.
Mm.
So let's get into the specifics. How does human civilization, what we call the Anthropocene, how are we leaving our mark on the planet geologically?
Right. So one of the biggest markers, like the most significant one, is the change in stable isotopes, particularly carbon. You see, isotopes, they're like fingerprints. They reveal all these details about past events. And human activity, especially our reliance on fossil fuels, it's altering these fingerprints in a big way.
We're messing with the planet's chemistry, basically.
Yeah, pretty much. We're seeing this decrease in the ratio of carbon-13 to carbon-12, and that's a pretty clear signature of fossil fuel use.
It's almost like we're carving our signature into the planet's, chemical makeup.
Yeah.
But the paper argues that these Anthropocene markers, these changes, they aren't necessarily unique to us, to humans.
Right. That's a really important point. When we look at ancient rock layers, we see similar shifts in isotopes in certain periods. Like, for instance, there's this event, the Paleocene-Eocene thermal maximum, or PTM for short.
The PTM, right, right.
Yeah. It happened about 56 million years ago, and during the PTM, there was this huge rapid influx of carbon into the atmosphere, a big spike in global temperatures, and changes in sedimentation that look a lot like what we're seeing today.
So hold on, if both human activity and these natural events like the PTM can leave similar traces, how do we tell them apart? How do we differentiate between, say, a natural event and the impact of a past civilization?
Well, the paper suggests we need to look at the combination of markers, not just one thing in isolation. So, for example, the presence of plastics and persistent synthetic pollutants, those would be strong indicators of an industrial civilization, right?
Yeah.
Because those materials, they don't occur naturally.
Okay, yeah, plastics, they're kind of like I guess, a smoking gun in this whole scenario. But I'm guessing it's not always that clear cut.
You're right, it's not. You see, there are these events in Earth's past, events that involved significant carbon releases and other changes that, well, they kind of mirror what we see happening in the Anthropocene. So it makes it tricky to definitively rule out a civilization-driven cause.
So we could find similar fingerprints, so to speak, from both natural events and a potential past civilization.
Yeah, it's definitely a possibility, and that's why this whole thing is so challenging.
We're going to need some serious detective skills to untangle all of this.
Absolutely. And the paper, it stresses the need for more research into how long industrial byproducts last in the geological record. Like, we need to know what traces of our civilization, what's going to stick around for millions of years so that we know what to look for when we're searching for signs of a past civilization.
So we're not just searching for a needle in a haystack. We're searching for a very specific kind of needle, one that we can actually recognize.
Exactly. And it's not just about identifying specific materials either. The paper, it emphasizes how important it is to investigate unique chemical signatures, like signatures that industrial processes might create. These could be, anomalies that really stand out against the background of natural fluctuations.
Anomalies. You mean like unexpected spikes in certain elements or maybe strange combinations of compounds?
Precisely. And the paper, it even suggests a method to make these anomalies more detectable. It involves normalizing the data.
Mm.
Basically, you filter out the background noise of natural processes, so any unusual spikes, they'd be much easier to spot.
So it's like adjusting the contrast on an image to make certain features stand out more. That makes sense.
Exactly. A great analogy. And then, if we do find these anomalies, the next step would be to look at the fossil record, right? See if there are any potential candidate species from that time period, species that might have been that might have been capable of building a civilization.
So we're not just looking at rocks. We're also looking for fossils of creatures that had the potential for intelligence and technological development. Creatures that could have left behind uh, those anomalous traces we were just talking about. Wow, this is like a multi-layered detective story
Right.
spanning millions of years.
It really is. It's a fascinating puzzle, and we're just starting to put the pieces together.
This is getting really interesting. But let's dive a bit deeper into these potential anomalies. What kind of specific examples are we talking about here?
Well, one area that would be particularly interesting to look at would be unusual concentrations of metals. Metals that are associated with industrial activities. So, for example, we see a sudden spike in platinum group metals in a layer of rock. That could be a big red flag.
Because those metals aren't they're not usually found in such high concentrations, right?
Right, they're rare in Earth's crust, but they're commonly used in industrial processes.
So we'd be looking for signs of large-scale metal mining or maybe refining, things like that. What else? What other anomalies could we look for?
Another potential anomaly would be unusual isotopic ratios of nitrogen. You see, certain industrial processes, like the production of fertilizers, they can alter nitrogen isotopes in a way that wouldn't happen naturally.
So if we find these distinct nitrogen signatures in the geological record, that could be a pretty big clue.
Exactly. It would be like finding a chemical signature that basically screams, "Industry was here."
I like that. But okay, what about those events where we see these massive carbon releases, like the PTM we talked about earlier? How do we know for sure that those weren't caused by some ancient civilization burning through their own fossil fuels?
That's a great question, and it really highlights the limitations of our current dating methods.
Hmm.
You see, we can often pinpoint when these events occurred, but determining their duration with really high precision, that's still a challenge.
So it's possible that some of these events they happened over centuries or even decades, and that could point to a more rapid, potentially civilization-driven cause.
It's a possibility we can't completely rule out.
So even if it seems unlikely based on what we know now, there's still a chance, however small, that some of these events were triggered by a past civilization.
Exactly. We need to keep an open mind and consider all the possibilities.
Okay, but let's shift gears for a moment.
Mm-hmm.
You mentioned earlier that a past civilization, they might have used different energy sources, right? Sources that would leave a much smaller footprint on the planet. Could you elaborate on that a bit more?
Sure, sure. Imagine a civilization that had figured out how to harness, renewable energy sources
Right.
like solar, hydro, or geothermal energy. Their impact on the geological record, it would be completely different from ours.
They wouldn't be pumping all that carbon into the atmosphere from burning fossil fuels, and they wouldn't be leaving behind all those synthetic pollutants that we struggle with today.
Exactly. Their footprint might be so subtle, so faint that we could easily miss it with our current methods.
So, in theory, there could have been a technologically advanced civilization that lived in harmony with their environment, leaving behind barely a trace.
It's a fascinating possibility, and it reminds us that we're searching for evidence based on what we know, based on our own experience. But there could be, there could be a whole universe of possibilities out there, ways of building a civilization that we haven't even imagined yet.
Wow, that's a pretty humbling thought. Okay, but let's get back to the research paper for a moment. There was this one section that I found particularly interesting. It talked about the possibility of a connection between past civilizations and the formation of fossil fuels. It's a pretty wild idea.
Ah, yes. The authors they suggest that the initial release of carbon that triggered some of these past events, like those OAEs we talked about earlier, those ocean anoxic events, it's possible that those were actually caused by a previous industrial civilization, a civilization that burned through their own fossil fuels.
Wait, so you're saying that a past civilization's pollution could have actually created the conditions for our own industrial revolution?
It's a mind-bending concept, isn't it?
It is. So they might have triggered an OAE, which led to this massive burial of organic matter, and that eventually, over millions of years, that turned into the fossil fuels that we're so reliant on today.
Precisely.
So we're living off the consequences of their action.
In a way, yes.
That's both fascinating and a little bit terrifying if you think about it. It makes you wonder what kind of legacy we're leaving behind for future civilizations, or even for future generations of our own species.
It's a question we should all be asking ourselves.
I completely agree. Well, on that note, I think we should probably take a little break here, let all of this sink in. There's a lot to process.
Sounds good to me. Ready to dive back into the Silurian hypothesis.
Oh, absolutely. We've covered a lot of ground already. The challenges of finding evidence, the potential markers that both human civilization and past events can leave behind, and even the idea that a past civilization might have used energy sources that leave a much smaller footprint. Where do we go from here?
Well, the paper it lays out some pretty exciting directions for future research, and one of the key areas they highlight is the longevity of industrial byproducts. Those things we create that end up in the environment, specifically ocean sediments. We need to understand like what traces of our civilization are going to stick around for millions of years.
So we can basically use what we learn from studying our own impact to guide our search for evidence of past civilizations. That's pretty clever.
Exactly, and it's not just about those obvious materials like plastics either. It's about understanding those unique chemical signatures that industrial processes create. The kind of things that wouldn't really occur naturally.
So like a layer of sediment with a really strange mix of metals in it. That could be a clue, right?
Exactly. If something looks out of place, it might be worth a closer look. And then there's the whole challenge of identifying what the paper calls anomalies in the geological record from past events.
Anomalies, huh? So we're talking about like unexpected deviations from the normal patterns, things that might point to something. Well, something unusual, something extraordinary.
Yeah, exactly. It's like stumbling upon a piece of a jigsaw puzzle that just doesn't quite fit with the rest. It suggests that there's something more to the picture we're trying to put together.
So we're not just looking for a needle in a haystack. We're looking for a needle that doesn't even look like all the other needles. But what if we do find these anomalies? Then what? What's the next step? Well, that's where paleontology comes in. If we find these really intriguing anomalies in the geological record, then it would make sense to look at the fossil record from that same period. See if there were any potential candidate species that might have been capable of building a civilization.
Ah, so we need to find fossils of creatures that had the potential for intelligence, for technological development. We're basically searching for signs of intelligent life that could have left behind those anomalous traces we were just talking about.
Exactly. It's a multi-pronged investigation. We need to combine geology and paleontology
Sure.
to really build a compelling case. It's like a detective story that spans millions of years. It's incredible. Speaking of past civilizations, you mentioned earlier that they might have used different energy sources, sources that wouldn't leave such a big mark on the planet. Could you talk a bit more about that?
Sure, sure. Imagine a civilization that had figured out how to harness renewable energy,
Yeah.
things like solar, hydro, geothermal. Their impact on the geological record would be it would be so much different from ours.
Yeah, they wouldn't be leaving behind those carbon isotope shifts that we see from from burning fossil fuels, and they wouldn't have all those synthetic pollutants that are causing so many problems for us today.
Right. Their footprint might be so small, so faint that we might not even be able to detect it with our current methods.
It's amazing to think that there could have been a technologically advanced civilization that existed in harmony with with their environment, a civilization that left behind almost no trace.
Hmm.
But that also makes it even harder to find evidence of them.
It definitely adds to the challenge, but it also makes this whole search even more intriguing.
I totally agree. Okay, but let's get back to the paper for a minute. There was this one hypothesis that I found really fascinating. It was about the connection between past civilizations and the formation of fossil fuels.
Ah, yes. The authors they suggest that the initial release of carbon that triggered some of those big events in Earth's past, like the OAEs we talked about earlier. They suggest that those might have actually been caused by by a previous industrial civilization burning through their own fossil fuels.
Wait, so you're saying that that a past civilization's pollution could have actually led to the creation of the fossil fuels that powered our own industrial revolution? That's kind of mind blowing.
It's a pretty wild idea, isn't it?
It is. So they might have they might have triggered an OAE, and that led to this huge amount of organic matter getting buried, and then over millions of years, that organic matter transformed into the fossil fuels that we use today. It's like we're benefiting from their pollution.
In a way, yes. It's a pretty thought-provoking concept.
It is. It makes you think about the long-term consequences of our own actions, right? What kind of legacy are we leaving behind for future generations, or even for other civilizations that might come after us?
It's a question worth pondering.
Absolutely. Well, on that rather heavy note, I think we should probably take another short break here. Let everyone digest all of this. It's a lot to take in.
Agreed. A little break would be good.
Welcome back to the deep dive. We've spent this episode exploring the Silurian hypothesis, this idea that we could potentially find evidence of a past civilization in Earth's geological record. It's been a pretty wild ride.
It has. And as we wrap things up here, I think it's really important to remember that the authors of this paper they aren't saying that that a past civilization definitely existed back in the Silurian period. What they're doing is raising the question, and they're providing a framework for for how we might go about investigating it. It's about being open to new ideas and considering possibilities that that might have been dismissed in the past.
Yeah, it's about pushing the boundaries of our understanding.
Exactly. And even if we never find, absolute proof that a Silurian era civilization existed, just exploring this hypothesis, just asking the question, it can lead to some really valuable insights.
It makes us rethink uh, some of our assumptions.
Yeah.
Like our place in the universe, and whether we're really as unique as we like to think we are.
Right, exactly. And it raises all these questions about how civilizations evolve. Do they tend to rise and fall in these cycles? And if so, what can we learn from those who might have come before us?
It's it's a humbling thought, isn't it? The idea that we might just be one small chapter in this much bigger. Much longer story, a story that goes back millions of years. But let's bring this back to the listener for a minute. What are some key takeaways that we want to leave them with?
Well, I think the most important takeaway is that the Silurian hypothesis, even though even though it's still speculative, it's a legitimate scientific question. It's not just a thought experiment. It's a call for rigorous scientific
It's
investigation.
about it's about using the tools of science, things like geology, paleontology, chemistry, to explore a question that has some really profound implications for how we understand life and civilization itself.
Exactly, and it's a question that each listener can kind of think about on their own. Like, imagine just for a moment that you're a geologist, millions of years in the future, and you're digging through these layers of rock that represent our time. What kind of story would those rocks tell?
Hmm. That's a powerful image. Would it be a story uh, of innovation, of progress, or would it be more of a cautionary tale, a story about environmental destruction?
What would our fingerprint look like to those future scientists? It's something to think about, because in the end we're the ones who are writing that story right now.
And on that thought-provoking note, I think we're gonna wrap up this deep dive. It's been an amazing journey.
It has. Thank you for joining us on this exploration of the Silurian hypothesis, and we hope it's sparked your curiosity and maybe inspired you to keep exploring the mysteries of our planet and the universe.